This video is on rational exponents. If you recall that the nth root of a is simply equal to a raised 1 over n. And you have to keep in mind that n is a positive integer. In other words, it can only be 1, 2, 3, and so on. 2, 3, 4, and so on. So if n is 2, what we have is the square root. If it is 3, we have the cube root. 4, we have fourth root, and so on. So we have 81 raised 1 over 4, which is simply the fourth root of 81. And we want to write 81 in the fourth power of some number, because we see a 4 there, which would help us cancel things out. So we can realize that 81 is 3 raised 4. So those two would sort of cancel, leaving us with simply 3. But since this is an even root, we would have plus or minus 3. (64 raised 1 over 3 is simply the third root of 64. So we would want to write 64 as a third power of some number. And we know 4 to the power of 3 is 64. So these two would go away, resulting in simply 4. And we are not going to have plus or minus here because the root is an odd root. Here we could simply write x raised 1 over 4 as the fourth root of x. Now, we have to be careful about negative 16 raised 1 over 2, because the negative is outside the root. So this would be negative times the square root of 16. We could write 16 as 4 squared, so those two would go away, resulting in negative. But when we take the square root, it's plus or minus 4, and negative of plus or minus 4 is simply plus or minus 4. In the next expression, we have the fifth root of 32x raised 10. We want to write whatever expression that we have inside the root in powers of 5. 32 is 2 raised 5, and I could write x raised 10 as x squared raised 5. Reason being 2 times 5 is 10. Those two powers are identical, so I can combine them and write it as 2x squared raised 5. Now, the root cancels the power, and we would simply end up having 2x squared. So here we have the third root of 16 x raised 7, and we can simplify this in some ways, but eventually we are going to end up with a radical in the answer. What do I mean by that? So we could write 16 as 8 times 2, and we could write x raised 7 as x raised 4 times x raised 3. Using principles of exponents, if the bases are identical, we can simply add the powers. So 4 plus 3 is 7. So I'm rewriting x raised 7 as x raised 4 times x raised 3. Now, I could rewrite 8 as 2 cubed. And now I have two different cubic terms, 2 cubed and x cubed. So I can combine them and write it as 2x cubed, leaving behind 2 and x raised 4. I'm going to use the space over here. So since everything is in product inside, I can split the root and write it as the third root of 2x cubed multiplied by the third root of 2 times x raised 4. There is nothing we could do about the second term because we cannot write 2 the power of 3 in terms of an integer or sorts, and x raised 4 can be written in terms of a power of 3. So how would we go about doing this? Those two would disappear, leaving us with 2x. We could split this furthermore and write it as 2 times x cubed times x. So we have 2x times cube root of x cubed times the cube root of 2x. Those two would sort of go away, leaving us with 2x times x times the cube root of 2x. Now, certainly, cube root of 2x cannot be simplified further, so the answer is simply 2x squared times the cube root of 2x. So the section here is understanding a raised m over n. So we could write a raised m over n as a raised m raised 1 over n. So a raised 1 over n is simply the nth root of a raised m. So what we mean by that, it is the nth root of a raised m. So in the first problem, m is 3, n is 2. So 4 raised 3 over 2 is simply the second root of 4 cubed. A raised m. So that right here is a. In the next problem, we have to keep in mind that the negative is outside of 8 raised 4 over 3. And that is m, that is n, that is a. So we have negative 8, which is a raised m, raised to the power of 1 over 3. Which is simply the third root of 8 raised 4. And the negative is in the front. So in this expression, we have 3x plus 7, that would be a. M is 7, n is 3. So this would simply mean the third root of a raise m. So the answer is the third root of 3x plus 7 raise 7. So a simple property is that we could rewrite a raised negative m over n as 1 over a raised m over n. As an example, x raised minus 1 over 2 is 1 over x raised 1 over 2, which would mean x raised negative 1 over 2 is 1 over square root of x. X raised negative 1 over 4 is 1 over x raised 1 over 4, which would imply x raised negative 1 over 4 is 1 over the fourth root of x. Here we want to express these roots that we have, or the radicals that we have, in terms of positive exponents, and simplify if at all possible. So first step, we could write 64 raised negative 2 over 3 as 1 over 64 raised 2 over 3, which is simply the third root of 64 squared. We could also write this as the third root of 64 squared. We can interchange and write it that way. There is nothing wrong with that. And we know that the third root of 64 can be written as the third root of 4 cubed raised 2. And those two terms sort of go away. The root cancels the power. So we would simply have 1 over 4 squared which is 1 over 16. So I would like to make a note here. A raised m over n is the nth root of a raised m, or it is also equal to a raised 1 over n raised m. In other words, that is the mth power of the root of a. So they are one and the same. We could do it interchangeably. So here, the negative is in front of the expression. So it's negative 16 raised negative 5 over 4. We could rewrite it as 1 over 16 raised 5 over 4. I am going to move I'm going to write 16 raised 5 over 4 as the fourth root of a raised m, because a is 16, m is 5, n is 4. But keep in mind, we could also write this as the fourth root of 16 raised to the power of 5. So that would equal to negative 1 over the fourth root of 16. I could write it as the fourth root of 2 raised 4, raise it to the power of 5. And those two would sort of go away, and we will have negative 1 over 2 raised 5, which is negative 1 over 32. So key takeaway here is that we could write a raised m over n in different ways. We could either call it as the nth root of a raised m, or the nth power of the root, or the nth root of a. So it depends on how we want to simplify. And depending on the need for simplification, we have to choose the appropriate version. So here are some of the rules of exponents. So the first one, if the bases are identical, the base being a raised m times a raised n is a raised to the power of m plus n. Likewise, a raised m raised to the power of m or n here simply means we're going to multiply the two and write it as a raised to the power m times n. The next one has two different bases, a and b, but we are raising it to the common power, which in this case is n. So we have two different bases, a and b, but we have a common power, which is n. So we could apply that exponent to each of the bases and write it as a raised n times b raised n. The same argument applies for a over c raised n. I could take that n and apply it to a and apply to c and write it as a raised n over c raised n. So the quotient rule here is a raised m over a raised n. We can move the denominator to the numerator and we would end up having a raised negative n. The bases are identical, so we add the powers. So if we add m and negative n, we end up getting m minus n. So a raised m minus n. Keep in mind, any number raised to the power of 0 is 1, which is right here, and any number raised to a negative exponent is simply 1 over a raised to the exponent. So a raised negative n is simply 1 over a raised n. So we want to use the properties to simplify here. We'll start with the first one, x raised 1/2 times x raised 1/3. The bases are identical, so we can simply add the powers. We want to combine 1/2 and 1/3. We can do that if we have a common denominator, which is 6. So I multiply and divide the first fraction by 3. So 3 over 2 times 3 is 6. The second fraction I multiply and divide by 2. So 2 over 3 times 2 is 6. Now the bases are identical, so I combine the powers. 3 plus 2 is 5. So the answer is x raised 5 over 6. 1 over 4 squared is the same as 1 over 16. It is the same as 4 raised negative 2. When that moves to the numerator, it becomes 4 raised negative 2. And you could use a calculator to find the answer of 1 over 16. In the next problem, the bases are identical, which is y. So I'm going to combine the powers, minus 4 over 7 plus 6 over 7. They have a common denominator, which is 7. So I'm going to add the numerators, 6 minus 4, which is y raised 2 over 7. And if we have to write it as a radical, we could either write it as the 7th root of y squared, or we could write it as the 7th root of y raised to the power of 2. Both of them would work. So here we have an expression with a bunch of things going on. So we have the fifth root of 32 multiplied by x raised 2 over 3, entire thing multiplied or raised to the power of 3. Now, let's see if we can simplify whatever term that is inside the parentheses. I could write 32 as 2 raised 5. I'm writing it in the fifth power so that I can cancel the root and the power, times x raised 2 over 3 raised cubed. So we have 2 times x raised 2 over 3 raised to the common power of 3. So I could apply that power to each of those terms. So I will have 2 raised 3 times x raised 2 over 3 raised 3, which would give me 8 times x raised, another property of exponents. If we have something here, x raised to the power of something, which is raised to the power of something else, we could simply multiply the two exponents, so 2 over 3 times 3. Those two will get cancelled, and we will have 8 times x squared. So we can use the concept of rational exponents to simplify radical expressions, in the sense we could use the properties that we learned to simplify radical expressions. What do I mean by that? So here we have the first radical, the 8th root of x raised 4, which we could write it as x raised 4 raised 1 over 8. But we know here we can multiply those two. So x raised 4 times 1 over 8. The 4 and 2 would get cancelled. So we have x raised 1 over 2, which is simply square root of x. In the next one, we have the 6th root of 25, which we know can be written as 25 raised 1 over 6. But 25 is 5 squared. So I'm going to rewrite 25 as 5 squared. Now I know that we can multiply those two powers. So we have 5 raised 2 over 6, and 2 divided by 6 is 1/3. So the answer is the third root of 5. Here we want to combine the radicals using rational exponents. We know that square root of x is x raised 1 over 2. I'm rewriting the radical in terms of an exponent. The 4th root of x is x raised 1 over 4. The bases here are identical, so I can combine the powers. So we need to find the common denominator, which is 4 in this case. So I'm going to multiply and divide the first fraction by 2. So I have 2 over 4 plus 1 over 4. The denominators are identical now, so I combine the numerators and write it as 2 plus 1 over 4, which is x raised 3 over 4. I could write this either as the 4th root of x cubed, or I could also write it as the 4th root of x raised to the power of 3. Here we have the 5th root of 1/3, fifth root multiplied by the second root of 2. So 5 raised 1 over 3 times 2 raised 1 over 2. If you look at it, the bases are not identical. Those two are not the same. The powers are not the same. Could we do something with this? No, we cannot. So we simply leave it as is. So we cannot combine the two radicals because the bases are not the same, the powers are not the same. So we will just leave it as is.